All right, folks, this is going to be our last lesson in the laws of exponents. We've looked at the first two laws dealing with multiplication and division issues. We've also talked a little bit about what happens if we have a negative exponent or if we have an exponent that's a zero. Today, we're going to wrap it up with the idea of powers of powers. So, for example, here I've got 4 to the second power, and then that is taken to a third power. So that's what we mean by powers of powers. We're basically taking exponents of exponents. All right? So we'll see if we can work through a couple of these, see if we find any patterns that we can utilize to generate this third law. So real quick, first off, exponents simply mean to take the base. So in this case, if I'm looking at the 3 as my power, the base is 4 to the second. And it's telling me to take 4 to the second 3 times and multiply it together. All right, so let's do that. So I could rewrite this as 4 to the second multiplied by 4 to the second multiplied by 4 to the second. So there it is, 4 to the second done up 3 times. All right, there's a couple ways that we could solve this problem. The first method is to simply rewrite it. So I'm going to do that over here. I'm actually going to just draw an arrow and we'll rewrite it over here because we've got space. I know that 4 to the second power means 4 times 4. And notice we can do that a couple more times there. So there's that middle one, 4 times 4. And there's that last one, 4 times 4. Right. Well, I noticed that if I have all those 4s together, that's 1, 2, 3, 4, 5, 6 of them. So I could just rewrite this as 4 to the 6th, which works fine. There is a second way, however, if we use our first law of exponents. Notice this is products of powers. So I could take these 2's and simply do it this way. We'll keep our base, and we'll take 2, added to 2, added to 2. Well, that's also 4 to the 6th. Oh, excuse me, not 46. 4. Oh, good grief. 4 to the 6th power. There we go. Now we can write it. Well, the question is, instead of doing either of these options with all this work, is there a quicker way that we could have gone with 4 to the second taken to the third? Is there a quicker way to go from here to there instead of doing all the work? All right, well, think about it. All right, let's try another one. We'll do the same thing again. So again, I happen to have a power of 2 here. So our base in this case is 2 times 4, or x to the 4th. So we're going to take that entirety and square it. All right, so we've got 2 x to the 4th multiplied by 2 x to the 4th. So there they are, 2 of them. And again, a couple ways we could do it. One way is to write everything out. So for example, I've got 2 multiplied by 1, 2, 3, 4 x's. Goodness gracious. All right, and then multiplied by another 2 multiplied by 1, 2, 3, 4 of those. All right, we could rewrite it. I've got 2 2's, so that's 2 to the second. And then I've got 1, 2, 3, 4, 5, 6, 7, 8. So x to the 8th. All right, that's one option. Another option is to take what we learned, again, with our first law. I've got technically 2 to the first and 2 to the first. Remember, that 4 only applies to the x, not to the 2. So I could add those. So 2, 1 added to 1. And then we could do the same thing with our x's. 4 added to 4. Notice in both scenarios, we still end up with 2 squared multiplied by x to the 8th. But again, is there a quicker way? Instead of doing all that work, could we have gone from our original to our final answer in one step? And the answer is yes. All right, take a look. Our third law of exponents is powers of powers. And here's what it says. It says when you take powers of powers, you can simplify the expression by multiplying the power on the outside of the parentheses by each exponent on the inside. Again, we keep the bases the same throughout all of this. So let's try it. So instead of writing this 4 out, or 4 to the 7th out 5 times, and then writing those 4 to the 7th out, and then adding, what we can do is simply multiply. So I could rewrite this as 4 to the 7th multiplied by 5 there, and then just multiply it. Well, 7 times 5 is 35. Because notice, I would have 5 of these with 7 4s in each group. Well, 5 groups of 7 4s is just 35. So the quicker way to do it, instead of all this work like we did before, is to just multiply the exponents. All right, let's try it again. Notice in this case, I've got a little bit of work to do. We've got 2 times 3, so let's rewrite it. 2, 3 times 2 multiplied by 2 to the negative 4th. All right. Well, 2 times 3 is 6, so we could rewrite this. 2 to the 6 multiplied by 2 to the negative 4th. And remember, our first law of exponents tells us that if we have a common base, and we do, we can simply add. So I could rewrite this, and I'm out of space, so we'll do it down here. We'll have 2 to the 6th add negative 4, which is simply 2 to the 2nd. 6 added to negative 4 is 2. Cool. So I can go from here to there in a lot less work than it would be if I had to write out all those crazy 2's and start multiplying or adding, etc. All right, well, let's try this one. Now, notice a couple of things. First, this 3 only applies to x. All right, so that means this 1/4 as an entire value has an exponent of 1. So I'm going to write that right here. Okay. Now, some teachers would prefer you to, well, I'll show you. Let's multiply first. So I've got 1/4, all right, that whole value with an exponent of 1 multiplied by that 2 on the outside. All right. For our x, we'll do the same. We've got 3 multiplied by 2. So here's what we'll write. Some teachers, depending on who they are, will want you to go ahead and work this out. So for example, one way to write it out is just 1 times 2. So 1/4 taken to the 2nd. And then here, x to the 6th, again, 2 times 3. Some teachers, however, would want you to take this 1/4 and do the following. You could either write it as 1 to the 2nd over 4 to the 2nd, x to the 6th, or they'd want you to go ahead and work that out to make it 1/4 squared, so that's 16 x to the 6th. Personally, I like either this first version with a set of parentheses, okay, or this last version without the parentheses and simplifying out. I don't like this, what I'll call an in-between step. Again, some teachers like that. I do not. Either write it this way or write it this way. I would not write it that way. Again, that's more of an in-between step. Wouldn't do it. But either one of those answers I would accept. All right, let's do one more. Notice with this last one, all we're working with is variables. So again, as long as we keep the bases separate from each other, we'll be good. M has a 6 power. H has a power of 1, even though it's not written. X has a negative 4th power, and all of this is being taken to the 5th. All right, let's rewrite. M to the 6th multiplied by 5. H to the power of 1 multiplied by 5. And then x to that power, let's see, we had a negative 4 times 5. All right, let's rewrite them. We'll have m to the 30th, h to the 5th, x to the negative 20. Remember, negative exponents are not kosher, right? We cannot write those and leave them as a final answer. So what we're going to do is we're going to rewrite it, taking that negative exponent and moving it to the denominator. So let's write a final answer. M to the 30th, positive exponent, stays up top here in the numerator. Right? H to the 5th, also a positive exponent, stays up top here in the numerator. Negative gets dropped. We lose the negative on the way down, because remember, that's all the negative tells us, is move it to the denominator. Cool. And that would be our final answer here. So powers of powers, it's a simple game to play. All you got to do is multiply. So let's take some time. Here on the back, we've got some examples from all 3 of our laws. We'll work through these kind of fast. Again, if I'm going too quickly for you, hit pause. But otherwise, I'm going to pretty much fly through these, just so that way you've got 16 solid examples from all of the different laws. All right, so let's start off. I've got products of powers, so we'll add. So I'll keep the base, add 4's together, so 2 to the 8th. All right. Notice I've got coefficients here, so we can multiply those. So we can do 5 times 8 here in just a second. And then I've got v to the 1st, v to the 1st, and v to the 3rd. So that is v, 1, add 3. Right? So I've got 40. And then v to the 1, 2, 2, and 3 is 5. So 40, v to the 5th. Right? Here we've got our common bases, 4's, taken to the power of 4 add 3. So that is simply 4 to the 7th. Right? Notice we've got some different bases going on here. We've got x's, we've got 7's, and we've got 8's. So we could write this answer a couple of different ways. One option is to recognize that 8 doesn't have another power to work with, so we could just write it as 8. whereas 7 has a power to the first. So 7, 1 add 1. The x's, I've got x to the first, x to the fourth, x to the first. So that's x to the 1 add 4 add 1. And then we could write this out as 8 times 7 to the second times x to the sixth. Or we could go ahead and simplify our 8 and 7 in this case. Both answers would be considered acceptable. In this case, I'll show both. So we could have it as 8 times 7 to the second times x to the sixth. We could also go ahead and multiply 8 times, 7 to the second, which is 392 x to the sixth. I would accept either answer, though I think this answer here is a little bit cleaner. All right? Let's try division situations. All right, that's law 2. And remember, with law 2, we subtract. So we keep the base, so we don't divide the 6's here. We just hold on to them, that base of 6. And then we'll take negative 3, subtract 3 more. Well, that is 6 to the negative 6th power, which we'll rewrite as 1 over 6 to the 6th. Remember, once we move it down, that power, we drop the negative. All the negative tells us to do is move it to a denominator. We did, so we're golden. Let's try another one. We've got 8, so we keep that base, to the third, subtract negative 3. Remember, subtracting a negative from the beginning of the year. Add a line, change a sign. Makes it easier. We keep that 8, and we add 3 and 3, and that is 6. So 8 to the 6th. Let's try it again. Number 7. I noticed that I've got this 6 here that's sort of on its own. So when I rewrite my fraction, I'm just going to go ahead and leave the 6. There's nothing for it to work with. For our b's, I have b to the negative first, subtract a negative 2. So again, add a line, change a sign. That will give me b to the first power. And again, I don't write powers of 1, so I'll just write it as b. And then the 6 didn't change. Cool. All done. All right, let's look at number 8. For 8, we've got 6 over 4. Well, that is a fraction that could be simplified. Remember, our coefficients we'll just treat as normal. So 6 over 4 could be simplified to 3 over 2, and that's how I'll rewrite it. All right, I've got x to the third, x to the second, so we'll take x to the third, subtract 2. And then I've got 2 and 3 for my exponents for y, so y, 2, subtract 3. Let's see what we get. The 3 and the 2 hang out. They don't move. I get x to the first power, so that's positive, stays up top. I get y to the negative first, that means we drop it down here. So I've got 3x over 2y, and that would be our final answer. Okay. Let's try these last bits. Notice these are all powers of powers, just like we've been talking about today, and we multiply. So again, keep the base. So I've got 3 to the power of 3 multiplied by 3. So that's just simply 3 to the 9th. All right. Here I've got 4 to the second taken to the second. So we keep the base of 4. And then we'll take our power of 2 and multiply it by the other power of 2. In this case, we end up with 4 to the 4th power. All right. N to the second. I'm not sure what happened here. It looks like maybe we lost something there in translation. But ultimately, we couldn't do anything with it even if we wanted to. I wonder what happened to the rest of that problem. I'll have to look. Something didn't print right. All right, well, let's try number 12. Again, this 2 only applies to the m, so that means the 6 has a power of 1. So as we start multiplying, I've got 6 to the first multiplied by 2. And then we'll multiply that by m to the second, and that power of 2 also multiplied by 2. So that gives us 6 to the second, m to the fourth. So I would accept that answer. I would also accept if you wanted to go ahead and work that out. So 36 m to the fourth. I would accept either answer in that case. It's up to you entirely. All right, let's try 13. I've got x to the fourth, x to the third, and all of that taken to a power of 4. So I'll have x to a power of 4 times 4. And then y to a power of 3 times 4. All right, and remember, the x and y are there are multiplied together. That's what that means when they're side by side. We won't have to write the dot in our final answer. So I'll have x to the 16th, y to the 12th, and we're done. Simple as that. All right, for 14, notice we do have a coefficient here, so we'll go ahead and write its exponent of 1. So we got 6 to the first, x to the second, y to the third, and all of that taken to a power of 2. So here we go. I'll have 6, 1 times 2, multiplied by x to the power of 2 times 2, and then y multiplied by a power of 3 and 2. All right, let's rewrite it. So I could write that as 6 to the second, x to the fourth, y to the sixth. All right. You could also go ahead and multiply that out. So 36, x to the fourth, y to the sixth. I would accept either of those answers. All right, well, let's keep going. We're on a roll. We only got 2 more left. For number 15 rather, I've got 2x to the fourth. And remember, both of these, even though it's not written, have powers of 1. So when I multiply those through, I'll have 2 to the power of 1 times 4. And then that's multiplied by x to the power of 1 times 4. So at the end of the day, I've got 2 to the fourth, x to the fourth. Once we go ahead and work that out, if you wanted to, again, this is perfectly acceptable. You could also rewrite it as 16x to the fourth. Again, 2 times 2 is 4, times that third 2 is 8, times that fourth 2 is 16. So either of those answers would be fine. They mean the same thing. Last but not least, goodness gracious, we're almost done. Problem 16. So again, we've got 8 to the first, v to the negative third. Remember, this negative 3 only applies to v, not to the 8. So I've got 8 to the first multiplied by 4. And then we've got v to the negative third multiplied by 4 there. All right, so let's work it out. That gives us 8 to the fourth multiplied by v to the negative 12th. Again, negative exponents, no go there. So let's rewrite it. We'll write it as 8 to the fourth over v to the 12th. If you did want to go ahead and work out 8 to the fourth, you are okay to do so. However, let me point this out. If I take 8 to the fourth, that's 4,096 over v to the 12th. And I don't know about you, that's a lot to write out. And in this case, 36, rewriting that's not such a big deal. This, on the other hand, that's kind of a big number. Personally, I'd rather stick with that. Though again, if you did give me the other answer, it's not wrong, perfectly valid. But personally, in a case like this, I would stick with something that keeps my amount of writing to a minimum. All right, that's basically it, folks. That's our third and final law for exponents. If you have any questions, any concerns, please ask. We'll be doing multiple examples in class together. But again, if you have any questions or concerns, please make sure you write them down on your notes. Bring them with you to class so that we can discuss them. All right, have a good day, folks. We'll talk to you later.